Eclipses are among the most fascinating celestial phenomena, captivating humans for millennia. These events occur when one celestial body moves into the shadow of another, creating a temporary blockage of light. The study of eclipses reveals not only their awe-inspiring beauty but also their predictable patterns, rooted in the mechanics of celestial motion. At their core, eclipses result from the alignment of the Sun, Earth, and Moon, with the type of eclipse, solar or lunar, depending on the order of alignment. A solar eclipse occurs when the Moon passes directly between the Earth and the Sun, casting its shadow on Earth. Conversely, a lunar eclipse happens when Earth positions itself between the Sun and the Moon, casting its shadow onto the Moon. The fundamental requirement for either type is that these three celestial bodies align in a straight or near straight line, a condition known as syzygy. The mechanics of eclipses are governed by the orbits of the Moon and Earth, both of which are elliptical rather than perfectly circular. This orbital shape means that the distances between these bodies vary, influencing the apparent sizes of the Sun and Moon as seen from Earth. When the apparent size of the Moon is sufficient to completely cover the Sun, a total solar eclipse occurs. If the Moon appears smaller, it leaves a ring of sunlight visible, creating an annular eclipse. Partial solar eclipses occur when only part of the Sun is obscured. The inclination of the Moon's orbit, tilted about 5 degrees relative to Earth's orbital plane, plays a crucial role in the frequency of eclipses. Without this tilt, eclipses would occur every month during the new and full moons. However, the tilt means that the Moon usually passes above or below the Sun-Earth plane, making eclipses rare events. They can only occur when the Moon's orbit intersects the Sun-Earth plane, at points known as nodes. The alignment must coincide with a new moon for a solar eclipse or a full moon for a lunar eclipse. Eclipses exhibit remarkable predictability due to celestial mechanics. The Saros cycle, a period of approximately 18 years, 11 days, and 8 hours, allows astronomers to forecast eclipses with great accuracy. This cycle arises because the Moon's orbit, its inclination, and its distance from Earth repeat in a predictable pattern. A solar or lunar eclipse that occurs today will have a near-identical counterpart 18 years later, though the location and visibility of the eclipse on Earth will shift due to the cycle's non-integer duration. Throughout history, eclipses have held deep cultural and scientific significance. Ancient civilizations, such as the Babylonians and Chinese, meticulously recorded eclipses, associating them with divine or ominous events. Over time, these records contributed to the development of early astronomy, allowing civilizations to refine their understanding of celestial motion. By the time of the Greek philosopher Hipparchus, eclipses had become valuable tools for calculating the size and distance of the Moon and Sun. Modern scientific inquiry has further illuminated the importance of eclipses. Solar eclipses, for instance, provide a rare opportunity to study the Sun's corona, the outer layer of its atmosphere, which is normally obscured by the Sun's brightness. Observations of solar eclipses in the early 20th century played a pivotal role in confirming Einstein's general theory of relativity, as scientists measured the bending of starlight by the Sun's gravity. Lunar eclipses, though less dramatic than their solar counterparts, also hold scientific value. During a total lunar eclipse, sunlight passing through Earth's atmosphere scatters shorter wavelengths and allows only red light to reach the moon, giving it a reddish hue, a phenomenon known as Rayleigh scattering. This effect offers insights into Earth's atmospheric composition and has even inspired studies on the habitability of exoplanets. Eclipses follow intricate long-term patterns beyond the Saros cycle. Over centuries, the geometry of the Earth-Moon-Sun system changes due to gravitational interactions, causing shifts in eclipse patterns. These phenomena, known as eclipse seasons, occur roughly every 6 months when the Sun is near the Moon's nodes. Within these seasons, conditions are ripe for both solar and lunar eclipses, although not all alignments produce visible eclipses. The interplay of celestial mechanics ensures that no two eclipses are ever identical. Variations in the duration, path, and magnitude of eclipses arise from the complex motions of the Earth and Moon. For example, the Earth's axial tilt and orbital eccentricity influence the length of the shadow cast during a solar eclipse, while the Moon's elliptical orbit affects the size and clarity of the Earth's shadow during a lunar eclipse. Looking into the future, eclipses remain a source of wonder and a reminder of our place in the cosmos. Advances in technology allow for precise predictions and observations, turning these events into opportunities for education, research, and public engagement. As humanity continues to explore space, eclipses will undoubtedly remain a celestial phenomenon that bridges our past, present, and future, inspiring awe and scientific curiosity alike. The exploration of eclipses extends far beyond their immediate visual spectacle. Their influence reaches into various scientific domains, cultural interpretations, and even future possibilities tied to human exploration of space. These additional chapters delve deeper into these aspects, broadening our understanding of eclipses and their enduring significance. Eclipses is a tool for planetary science. Eclipses have become a powerful tool for studying not only our own planet but also other celestial bodies. During a solar eclipse, the temporary darkness allows scientists to measure temperature changes in Earth's atmosphere and surface. These observations provide data on heat retention and energy distribution in different ecosystems, aiding climate studies. Similarly, during lunar eclipses, the Earth's shadow on the Moon reveals subtle changes in atmospheric dust and composition, offering a historical record of volcanic activity and other atmospheric phenomena. In the realm of planetary science, eclipses on other planets provide unique insights. For instance, observations of Jupiter's moons casting shadows on its surface have revealed details about their orbits and the dynamics of the planet's atmosphere. Exoplanetary research also uses the principles of eclipses to detect planets around distant stars. When an exoplanet passes in front of its host star, it creates a transit that dims the star's light, allowing astronomers to infer the planet's size, orbit, and even atmospheric composition. Cultural legacy and modern celebration. The cultural significance of eclipses has evolved over centuries, transitioning from omens of doom to celestial spectacles that unite global audiences. Ancient myths often depicted eclipses as battles between gods or creatures consuming the sun or moon, inspiring rituals to rescue the celestial bodies. Modern interpretations have shifted, with eclipses seen as opportunities for community gatherings, education, and celebration of science. In many cultures, solar eclipses inspire festivals and viewing events, where people come together to witness the fleeting moments of darkness. Governments and organizations prepare extensively, ensuring public safety while fostering engagement. Lunar eclipses, less dramatic but more accessible, often serve as gateways for amateur astronomers to explore the night sky, inspiring a new generation of skywatchers. Eclipses in the age of space exploration. As humanity ventures deeper into space, eclipses take on new dimensions of importance. For astronauts aboard the International Space Station, ISS, eclipses offer rare views of Earth's shadow on the Moon or the Sun's corona from a vantage point beyond the atmosphere. These phenomena serve as reminders of the interconnectedness of celestial bodies and the vastness of space. Future lunar missions, such as those planned under NASA's Artemis program, may leverage eclipses for scientific exploration. For example, studying the effects of Earth's shadow on the lunar surface could provide insights into temperature extremes and inform the design of habitats and equipment. Similarly, eclipses observed from other planets could provide crucial data for understanding their atmospheres and potential for supporting human life. The role of eclipses in space weather monitoring. Eclipses also contribute to our understanding of space weather, the interaction of solar activity with Earth's magnetosphere. During a solar eclipse, the sudden removal of sunlight affects the ionosphere, a layer of charged particles in Earth's upper atmosphere. Scientists can use these changes to study ionospheric dynamics, which are crucial for understanding how solar storms impact satellite communications and navigation systems. On a larger scale, solar eclipses provide rare opportunities to study the Sun's magnetic field and coronal mass ejections, CMEs, which can cause geomagnetic storms on Earth. By observing these events during an eclipse, scientists refine their models of space weather, enhancing our ability to predict and mitigate its effects on technology and infrastructure. Eclipses in the distant future. The patterns and frequency of eclipses will change over millions of years due to the gradual shifting of celestial mechanics. The Moon is slowly drifting away from Earth at a rate of about 3.8 centimeters per year, a phenomenon caused by tidal interactions. Over time, this movement will affect the apparent size of the Moon, making total solar eclipses increasingly rare. Eventually, the Moon will no longer completely cover the Sun, and total eclipses will cease to occur. This inevitable evolution highlights the fleeting nature of total solar eclipses as a phenomenon unique to the current era of Earth's history. In the far future, humanity's descendants, perhaps observing eclipses from other planets, may look back at these events as a symbol of the interconnected forces that shaped our understanding of the universe. Eclipses remain a profound intersection of science, culture, and wonder. As humanity continues to observe and explore these celestial events, their significance only deepens, offering a bridge between the predictable rhythms of the cosmos and the ever-expanding curiosity of human understanding. Whether viewed through ancient myths, cutting-edge science, or the lens of interplanetary exploration, eclipses will undoubtedly endure as a source of awe and inspiration for generations to come.